I'm Tyler, and Ben, Leah, Chip, Ray, and I are Group 1. Our project was to build a collapsible bridge. Today, we will be explaining what a bridge is, the criteria and design of our project, planning and materials we used, how we assembled our collapsible bridge, the problems we encountered and how we solved them, the Fed presentation, and what we learned from the project. The first bridge was made in the 1700s by a farmer named James Finley. The American Association of State Highways Transportation Officials defines a bridge as any structure that spans at least 20 feet that is a part of a highway located over or under another highway. A collapsible bridge for our purpose is a bridge that can be collapsed to fit inside of 1 cubic foot and when expanded can span a 3-foot gap, and will be built from wood rather than materials such as concrete and metal alloys. Some of the criteria our collapsible bridge had to meet consisted of spanning a 3-foot gap, weigh less than 20 pounds, support at least 40 pounds, and collapse to fit inside of 1 cubic foot. Our design started by understanding what a collapsible bridge was, and then looking at the reason we were building a collapsible bridge. After many sketches, we decided on what seemed like the most reasonable solution. This consisted of hinges and boards that would be able to fold into 1 cubic foot, with cables and sideboards to support the bridge. Our planning consisted of building the bridge out of light, strong wood and using cables to add additional support. Then, to be able to fold, we decided to use hinges. We then gathered the tools to build the bridge. Once we began to build the bridge, we fixed any issues we came across. We gathered our materials from Home Depot, which consisted of wooden planks, hinges, steel cables, nails, and spray paint. The tools we used to construct the bridge came from 2 of the team members' toolboxes. On the first day of assembly, we planned well, which led to us being quick and efficient that day. After constructing most of what we could, and encountering a few problems, we realized we needed a few more materials before we could continue the project.
The first issue we encountered with the bridge involved the collapsing portion. We designed the bridge to put the weight on a plank rather than a hinge, which would give an odd number of planks. However, this design did not fold up, so we accounted for it by adding 1 extra plank. The additional plank fixed the problem effectively. The second issue involved the measurements of each board. Each board was originally planned to be 8 inches, but when the bridge collapsed, the planks stuck out past the rest, violating the cubic foot space. Instead, we chose to make the pieces on the end 6 inches and the middle pieces 8 inches. This made each piece fold flush with the top edge of the side pieces. The last issue involved the support forces acting on the bridge. Any weight placed on the bridge caused the end pieces to collapse toward each other. By running a cable below the bridge from end to end, it balanced the forces across the end pieces to allow the bridge to stand. It also made the bridge a bit more strong by adding elastic potential energy. At Fed, the bridge only supported the 40 pounds for a few seconds. This did not quite meet the criteria for the load. The cables running to the end pieces caused the boards to want to separate. This pulled the screws out of the holes, causing the screws to strip, rendering the hinges ineffective. The force acting outward on the board was much stronger than the screws were intended to support. In hindsight, we should have run cables to each individual board rather than just the end pieces. This would have distributed the forces more evenly and would have made the bridge support much more weight. The hinges would have then flexed, allowing more weight to be placed on the bridge before it reaches its limit. We learned that testing should have included all criteria and that lack of testing can result in unforeseen circumstances. We also learned to think ahead to problems that may arise and establish contingency plans. And most of all, we learned that every experience is a learning experience, and as long as we learn from mistakes, we cannot make them again.